Welcome to today's Essential Learning Target, perimeters of composite figures. Composite would mean that we're putting more than one figure together, so a square plus a triangle, like right here, or a rectangle and a semicircle all put together. Remember that perimeter, our new vocabulary word, not up there right now, we have composite vocabulary word. Perimeter is an old one. Perimeter means that you're going around a figure. You're not filling it up like volume, and you're not going on the inside like area. So you want perimeter, you want to go all the way around it and see exactly how far it is all the way around. It's going to be a distance, so our labels are going to be just regular labels. They're not going to be cubed, they're not going to be squared, just regular distances. So let's get started with our first one. Sometimes they will give you a figure that is on a grid. So the grid you would have would usually go all the way around the figure. I just drew this one quick. So it's not quite perfect, but it's okay. Pretend these are straight lines. Pretend we have all that. Mistake a lot of people make is they start counting squares, and they would get the area, but that's not what we're doing here. We're going with perimeter. So if you're checking out the perimeter of this, the first thing we want to do is figure out the easy parts, the parts that we definitely know. So if you look at the bottom of this, I like to start at one corner, so I'm going to start right here. I'm going to just do this part right across here. Now remember, we're going to count how many squares it is across. So what I do as a trick is I kind of count the squares with my marker pen as I go. There's 1, 2, 3, 4, 5, 6. And then I put a big 6 out here, so now I know. Well, there's another one that's just like that 6 up here. That's exactly the same. So this would be 6 up top. How many would it be across here? 1, 2, 3, 4. So I got 4 there. So now I have almost half of the thing done. I'm pretty close. These are a little bit tricky. If you look close, 1, 2. You're kind of thinking, yeah, but it's only half of that thing. It doesn't matter. We're looking at from here to here. That's exactly 2 across. So I have 2 there and 2 there. Notice how we're using similar parts to figure out each other. Now we have these diagonals. The big mistake you'll make is they count the diagonal as 1. But if you actually were to line it up, the diagonal is 1.5 for each of them. It's not exact, but it's about 1.5. That's where we get that about thing going on. So if we count how many we have here, we have 1, 2, 3, 4. If I go 4 times 1.5, I can figure that out really quick. I would end up with 6. So this would be 6 here, that would be 6 here. If I add all of that together, I should get my answer. So let's check it. Let's take a look as we go. So I got 6 and 4. I'm going to count that as 10. 10 plus 6 is 16, 17, 18, 19, 20. We got 26, we got 32. And the answer for this problem would be 32 units, I guess. They don't give me inches, they don't give me feet, so it would just be units would be the perimeter. So think about this when you're putting up a fence, or you're trying to go around something. That would be your perimeter. And the two composite, why this is a composite figure is because there's two shapes here. Maybe you didn't see them right away. If we cover up this part, that's a triangle. And if we cover up this part, that would be a rectangle. So they put two of them together to make it, and that's why it'd be a composite figure. Okay, there's going to be a bunch of those where they're going to give you a grid. The only difference between my grid and their grid is their grid will be continuous. It'll go throughout the entire thing, and the shape will be inside, like in bold. But in this case, I just drew the grid part on the inside so you could see it. Remember to go from side to side and count how many squares there are across, and you'll be in good shape. Okay, let's try our second example. This is going to get a little bit more exciting. We're eventually going to be able to do this one on our own. So that's what we're heading towards right now. It's a semicircle, although it's not drawn very well, and it's going to have a triangle connected to it. So let me draw one of these for us so we can try one together, and then you can try that other one on your own. All right. So I'm going to draw this, and my drawings aren't always perfect, but I do the best I can with it. Same thing with you. This is an art class. We're in math, so we just need a simple diagram to make it look as good as possible without being exactly perfect, but still to scale enough where we're not going to have a really, really weird figure as far as it goes. So I'm going to draw a triangle here first. Let's make it a right triangle, 90 degrees right there. And then I'm going to stick this semicircle on. This is where it usually gets a little hazy. So I'm going to stick this semicircle on top. There we go. Now they gave me some things that I can put in, some givens. So here we go. We'll have, this is going to be 8 feet for this side. This bottom part is going to be 6 feet. And the semicircle, they don't tell me the outside because that'd be what we're looking for. But they are going to give me this hypotenuse alongside the triangle. So that's going to be 10 feet right here. Now, what a lot of people do with perimeters, they start to add up those three numbers and they say that's the answer. But remember, this is the perimeter, this is the outside. We want to go all the way around this. Could be an irregular shaped pool or some other area we need to fence in. Maybe a baseball field. It could look kind of like that. So the first thing we do is we say, what do we already know? Well, on the outside, I definitely know I got 6 here and I got 8 here. So if I add up 6 and 8, I know part of my answer is 14. Now I got to add this part, the semicircle part. So this is where we're going to get into some of these things with pi and radius and diameter and all those. So the first thing we need to know is the distance around a semicircle is 1/2 the circumference of a circle. That sounds like it's pretty confusing. Let me just put the formula up here so we have it. All right, so we want to take the circumference of a whole circle, but I don't have a whole circle. I want a half circle, so I'm going to cut it in half. Make sense? Half circle, cut it in half. I think it sounds about right. So the circumference would be pi times diameter. That'd be for the whole circle, but I don't want the whole circle. And then when I'm all done, I'm going to divide that by 2. So how do we do that math? Well, what do we know? What can we plug in? I know what pi is. Pi is going to be 3.14. Do I know the diameter? Diameter means all the way across. Yeah, I got 10 right there. So I could plug in 10 right there. But normally I'd rewrite it. I'm just going to put it on here like this. So pi times 10. Now, will that work? Should. So this is a case where a calculator could work out really, really well. So I'm going to take this, and I'm going to actually rewrite it. 3.14 times 10 divided by 2. Now, there's a lot of calculating you can do here. The simplest way to do it, I think, is just to multiply the top first and then divide it by 2. You could do some other simplifying tricks as you go. Again, a calculator here would be worthwhile, or maybe you can do it without a calculator. It's up to you. So if we go 3.14 times 10, if you plug that into your calculator, you should end up with 31.4. We're going to divide that by 2, and we end up with a total of 15.7. Now remember that 15.7 is just for this part right here. So I want to take this 15.7 and my 14, and because it's composite, I'm going to put them together to get my total. So if I go 14 plus 15.7, if you can already see it, you have it figured out. If not, you could rewrite it on your scratch paper. Remember to line it up though. And we end up with 29.7. What do we have for label? Our label is feet. So I'm going to stick a little FT up there, box it so it looks pretty, and I have 29.7 feet for my answer. We're going to try one more. And this one I want you to try on your own, and we're going to see if you can figure it out. So it's just like this one, but it's up here. The numbers are a little bit tricky to see, so let me point them out. We got 24 centimeters, we have 10 centimeters, and we have 26 centimeters. Pause it here, try to figure out how to do this one, and take your best shot. If you get it right, awesome. If you don't, we'll try to figure out and dissect where it went wrong. Go ahead right now, try it out. Okay, so if you paused and you came back, you tried it, you tried to figure it out and see what you got. The answer that I got when I solved it was about, remember it's about because it's not exact here. We have pi included, so in case we're going to figure out all the digits, we're not going to get it exact. But the answer that I had for it was about 74.82 centimeters. At this point, you have enough knowledge where you can figure out the perimeter of a lot of different composite figures. The trickiest ones are the circles or semicircles. So when you have those included, you should be able to add them together at the end. I'll include some extra practice for you, and hopefully you'll be able to get these done really quickly, really easily, with a lot of confidence. Thanks a lot. See you next time.